Hello and welcome to another video from In3D Software. Today we've had a request from one of our existing customers on how he can best implement a specific type of fitting that isn't in the system already. So this is a question that we get asked quite a lot, and it relates to just how you intend to actually use the fitting and what the existing data that you have available is used for. So in this case, the customer has provided us this information from Hafele, and we have here a guide rail for 17mm groove drawers. And when we look at the picture here, it's some sort of like plastic doodad that you screw into the side of the cabinet and then groove into your drawer box. However, our customer doesn't intend to use it this way. He would like to use it as a spacer vertically to slide his samples in his showroom in and out of, which is quite a nice alternative use case for this particular type of fitting. If we have a picture here, we've got the fitting. Now, what's really handy is if we go down here, you can see that we have CAD data supplied by Hafele, so you can actually, request this CAD data if you don't have it already. Now, that's a really handy little get around here. However, that's not always the case. So what I'm going to do is create this particular fitting in here. And we can see that it's overall 350mm, and we've got some dimensions in here of 16mm. And if we look at the picture here, we've got 11 by 16, and we've got some 8mm holes, and then we've got the overall spacing of the holes in here. So with that in mind, one of the easiest things that we can do is actually create that fitting from scratch using the 3D modeling tools within IMOS. So obviously IMOS is based on AutoCAD technology, so we can just use these settings. So what I'm going to do is I'm going to save a copy of an existing fitting, and then I'm going to manipulate the data to get to the end result that I want. And that's generally the easiest way to approach any of these types of tasks within IMOS. There's no point in reinventing the wheel. If there's something in the system already that's kind of the same, why not start from there? Okay, so when I look at this use case of what we want to achieve, my immediate thought is that this is effectively a bigger, more complicated dowel, a wooden dowel that would be used for fixing a shelf or a partition. So that's what I'm going to do. I'm going to go to my system in here and go to Article Designer, and I'm just going to put in a cube 500 by 500. Let's drag this out a little bit here just so that we can see everything. I want to put in a top, a bottom, a left, and a right. And then in here, I'll put in my partitions that I want to divide this up with. So I'll put in a partition in here of 1 to 1. Okay. So then what I can do is I can go to my partition. And you can see in here it's using C1 as its connector, which is great because I can then use the variables to specify that this is actually a dowel. So by going to the article related variables, we'll go to the construction, the connectors, the connection situation, and currently it's a cam. And if I type in here dowel, it'll pull through my stock dowel fitting. And then in here, what I can do is simply increase my level of detail, and you'll see now that I've got dowels used to space this out. Okay, so the next thing that I want to do is go to this fitting in here, and I'll just select the individual fitting just so that I've got this as a drawing. I can then find it in the list, and here's the name, the part name. And what I want to do is go into the actual part and then find within here the drawing. So once I've got the drawing name, which is this number, I'll then close this down and type the word open, go to the con DWG folder and paste the name in. Here's my dowel, which is my, I don't know what this thing is, but it's just a cylinder in here in AutoCAD. And what's handy is that this is already an 8mm diameter hole. So what I can do now is simply save a copy. And in this case, I'm going to copy the name that I have from the Hafele website, and I'll just paste it in here. Now when we paste, we tend to want just the information in here that we need. So I'll just get rid of a lot of this. We'll camel case it, and then I think what we'll do is we'll just put the code in here as well so that we can search on the code as well. So let's get rid of that, do underscore and paste that in. And I generally don't like dots in the names, so I'll get rid of those, and let's just save that. Okay, so this has now got a new name in here. And what I want to do now is effectively create the rest of this information. So here's the reference image that I'm actually going to be working off here. So I know that that is 6 mil in, and then I've got another one and then another one. So I can just grab this now and I can copy that and say that that should move back along the y-axis 128, and then that one should move back here 192. Okay, great. So this is my initial insertion point, and then I know by looking at the image off screen here, where's my other little picture with my dimensions, I need now a box. So I'll type the command box, and I want my center point to be 0, 0, 0, and then I want the length, or the overall length, to be 350. I want the width to be 16, and I want the height to be 11. And then what I can do is just move this now to that midpoint, and then move it back this way and say that this is 6 mil from the reference geometry in this direction. Let me just confirm that. Where is it? Yeah, there we go, 6 mil. Okay, so now that I have this, I just need to move that dimension down. So let's go back to the, oh, and that's 7.5. So what we'll do is we'll move this down 7.5 and press enter. And then if I just copy this up, what I can do is then just use subtract to say all of these three should be subtracted with this, and now I've got this, and then I can type the union and group all of these things together. So now this is what I've got. So it's a very basic model. I can obviously spend a lot more time putting radiuses and fillets and all that sort of good stuff on there, and if I want to, I can also apply materials to this as well, so that when we render it out it looks very, very accurate. But for now I'm happy, so I'll just type save as again, and I could have just typed save, but what I want to do is copy that name, and then what I want to do is go into my system now and find that dowel hole. So here it is as a dowel, and I'm just going to paste that name in there the same as well. So I'm going to call this a grooved draw, and then paste that name in. So that was 430 underscore 15 underscore 765, and then I'll paste that draw in here as well. So let's just paste that in for now. So that's my drawing. And then in here, I also want this 8x15 millimeter drill, and I'm going to edit this and paste that name in there as well. Again, get rid of that. So I've now got my work group in here, and I've got an 8 by, what was my depth here? 7.5. So let's do 8 by 8 just to be safe. And then I want to duplicate that, and I want to shift in the Y direction 128. And I want to duplicate that, and I want to shift it in here. Let's just do a quick calculation. 128 plus 192, was it? I can't remember. 320, yep. So in here, 320, save that, done. Okay, so now that I've got my drill holes in position, I can click apply, save that, and that's now my new connector. And obviously I can come into here and I can start filling out all of my commercial information, the product codes, etc., all of this sort of good stuff, because this is what we want coming through on our paperwork. And don't forget a price. Okay, so Now that I've got my dowel, the next thing that I want to do is make a new fitting in this case. So I'll go and find this dowel and then go to usage, and you can see it's used within this connector set. And that means that I'm now a higher level up. I can now use the same name. So we'll call this plastic runner and give it a name. I can save that. And then in my filter, I can put this in as well. And that will allow me to then filter it. But because this is such a specific fitting, I don't really need connection scan to give me the option to choose multiple versions of this, unless, for example, it was coming in different lengths or different thicknesses or different colors perhaps. But for now, we'll just save the connection set. And then what we want to do is discard that and close. And then we'll go back to our initial drawing, and into here what we want to do is go to the variables again. So we'll right click article related variables, select the product, and then within the product we'll go to dowel again, and this time I'm going to rename dowel to be plastic runner, change from connection scan to direct selection, paste in the selection name, and then that's it. Let's put this in, and for now I just want a linear division of 1 to 1. We'll save this and then say, rather than being centered, this should be to the bottom face of part 1, and then click apply. I can then click apply again. Oh, I think we need to make another change. Let's go to article related variables. And in here, we'll paste it in. Now, this is being used as a fit-in on all of the corners, so we don't want to get in the way in here too much. So it's using this fitting. So let's run the article related variables again. Go to the runner, and then here's the connection set, and you can still see it's using that dowel, so that's no good. What we want to do is go into the library and then choose this thing, save that, click apply, save that, click apply, and then in here close that down. We can refresh. Okay, so we now have this effectively set up. So what we want to do is move these around so that they're orientated correctly as to how we want them to behave. So for example, this needs to rotate 90 degrees, it needs to be lifted up the 11, and then we need the additional fitting taken out of that as well. So let's go back into our part. I'll just select in here 3D editing on, and yeah, we can see that we've got those fittings in there ready to go. So they just need to be rotated around as well and moved down. Okay. So into Element Manager, and this is where rather than going in and out of Element Manager, we should always use Organizer, because by having Organizer open and off screen, we can quickly make the changes, refresh the data, and that will then update the model, and then we're not constantly going in and out of Element Manager via CAD. So if we go into Element Manager here, I want to then go back to the connector set. So let's go to hardware, and this is just happening off screen here, but it'll give you a chance to see the live updates so that I can get these positioned as we go through. So I'm just going to click on the fitting, and then in here I'll just want to get rid of my second subassembly. So if I get rid of that, because obviously as a dowel, let me drag this across here so that you can see. So as a dowel, I have 2 drill-ins, and I don't necessarily need 2, I only need 1. So let's get rid of that and just keep this as the initial fitting. I don't want that -11 position in here for the Z. I do want an orientation, so let's say 90, save, and then in here I'll do a refresh, and you can see that's moved it over and then up. And then what I want to do on my drilling in here, 3D editing on, is change that this part should be referencing this part down here, and the machining should also rotate. So we'll go back to the machining, say that this part number should be 0, and then in here I want 90 degrees on that orientation. We click save, right click, refresh, and now you can see that the machining is correct. However, if we just again turn 3D editing on, you can see that it's orientated the wrong way. So what I want to do now is go back into here and say that that should be rotated, the machining should be rotated, let's say 180 in Y. Save that, refresh, and now the drills are facing the correct way, but now it's centered on here and I need that offset to be brought over and then down. So in this case, I can do a distance command and say from here to here, it is 6 millimeters. So what I want to do is jog this over 6 millimeters. So back into here, I can say my insertion point in X should be 6 and 6. Actually, let's do a little bit of a tolerance in here. So let's say 7 and 7, because obviously this is going to be based on the thickness of the material. And again, this is why I've decided to do it as a dowel, because by having it associated with a part that I know that I'm going to be putting in, wherever I put that part, it's always going to reference the thickness of the part and move it over accordingly automatically. I don't want to be in a situation where I have to go in, start changing formulas, start moving things around just because I've changed the thickness of a part. So by clicking save in here, I can then refresh again. Oh, that's just moved it along in the length, sorry. So let's go back in, change that 7 in here to be 7 in this direction. There we go. Save. Refresh. There we go. And, oh, I didn't do a very good job of measuring there, did I? From that center point to that point there. Let's go into the front view. .5, so let's move it over an extra 1. So let's do 8.5. There we go. I can then refresh, and then I've got a bit of a gap here to one side. That's looking a lot better now. So don't worry about the fittings around the outside. These wouldn't be used. So effectively now what I can do is change my linear divisions, because that's what's controlling the position along the length in here. So if I go back to the article related variables in this case, what I can do is say that this should be in here, not 1:1, but let's say something along the lines of maybe 10 mil to 1. So that's going to bring it to up close to the front leading edge. And then if I refresh, that's going to bring it nice and close up to the front here. And then what I want to do is have that brought along the other way as well. So let's just modify it. And then in my linear division, I can say 25 mil to n times 22 millimeters to 1. So now when I click tick, that 1 plus 22 mil. That might just need to be 11 actually there. And click tick. Okay, now we've got a bit of an unexpected result in here, and that's okay, we can figure it out. So what's happening is, because the product is being flipped in here, we need to give it a handing, because what's happening is it's looking at its position relative to the overall dimension of the product. So what we want to do is have it so that it always knows that it should be from the outside. So if we go into the article related variables in here, well actually again it's probably easier if we go to the organizer, and then once we're in organizer we can then alter the settings within the connecting set. So if we go to element manager, we then want to go to construction, connection situations, And that should then bring up our plastic runner in here. And then we want the linear division to reference the minimum, and then the position relative to the onset part is the inside, and then bottom, let's just set to default for now. Refresh. And if we don't try default, let's try the others. So let's go in, and we want it all orientated to one side. So we want to choose a side. There we go. So we'd go to default, and let's choose the right side in here. And then if we then click save and drop that down, refresh. Okay, so now we're all facing one side, which is good. Let's go into a realistic view so we can kind of see the results in here. And then what we want to do is alter this top one. So in this case, the easiest way is to modify the product, go to the partition, and because this is a specific type of partition in here that's going to have maybe some sample doors in here, we would probably create a new construction principle. So let's say this is plastic guide runner as the fitting, and then in here this would be doors, right? And then in here we would do there we go. There we go. And then in the construction, you can alter offsets and things like that. And we'll go to the connector and choose the plastic runner in the bottom and the top. And then we need a reversed version of that in here. So R, and then what we can do is say that that should be to the left, I guess. Let's save that, apply that. Tick. There we go. If we then go back in article related variables, we just want to quickly change this now to be, I don't know, the original dowel fitting that we were using to knock this cabinet up. And click apply. Okay, so what's nice about this product now is based on the linear division, that's just going to continue to add these in. So I can now come in and say that I want to stretch that product all the way along. It's going to add in more doors, it's going to add in more dividers, and I've now got my plastic fitting with those drill holes in there. If we go into my size in here, I can then go to drawing views and quickly create a part drawing view for that top panel there with the appropriate drill holes all detailed out for me. Thanks for watching.